out the variance on one single variable. But conditional expectation is especially finding out the expected value or the mean and the variance, especially with respect to a conditional probability. Given x equal to something, find out the expected value. And one more thing that is being discussed in this chapter is the compound distribution. So like, okay, there is a mixture of uh, a Poisson distribution. Let's say we are talking about claim amount. There could be probably the whole total claim amount. I can break it into two parts. What could be is number of claims and probably average claim amount. These could be the two elements which I can take together to compute my total claim amount. And it may so happen that the total number of claims may be modeled using some discrete distribution, like a Poisson or some kind of a distribution, because number of, it's a discrete. Whereas average claim amount, I can have it as some conditional distribution, some continuous kind of a distribution, like a log normal or something like that. Now, when I'm combining these two, which can give me the claim amount, total claim amount prediction. The model for the total claim amount may come through this route. So there is a mixture of one discrete as well as a continuous kind of a distribution. Those kind of things we are associating it to compound distribution. So we will have to deal with even those kind of situations in this chapter. So to start with, so when we look at the conditional expectation, it is like you are finding out the mean given some other condition, like given x has already occurred. How do I find out the expected value of y? Again, this could be possible in a discrete case as well as a continuous case. Right? Earlier we have done just the scenario of expected value of x, or we have found expected value of y, variance of x in isolation. But now we are talking about assuming that x has already occurred, find out the expected value of y. So that is the scenario of conditional expectation. So just by taking one example, we can see how we can accomplish in a discrete case. If I want to find out the expected value of x given y equal to 10. Expected value of x given y equal to 10. How do I find it out? So this is y equal to 10. Right? So logically, whatever we talk about the expected value, we talk in terms of the probability multiplied by the number. The value multiplied by the corresponding probability is what we are calling as the expected value always. So now the only thing which you bring in case of conditional expectation is given, because this is y equal to 10, you take only this as your scope and you make updated probabilities. What is the updated probability, which is the conditional probability itself? Because now you are given that y equal to 10. So the probability for x equal to 1 will become 0.2 by 0.4, right, which is 0.5. For x equal to 1, the probability is 0.5. For x equal to 2 also, the probability is 0.5. So now the expected value is nothing but 1 into 0.5 plus 2 into 0.5, which is coming out to 1.5. Given y equal to 10, right? If nothing is given, probably just to remind of our joint probability scenario. If nothing is given and it is asked to find out the expected value of x, right? What is that we have done? Without the probability being given, if I wanted to find out the expected value of x, we have taken it as you take all y's, right? So probably x equal to 1 and x equal to 2. Here the probability is 0.5. Here the probability is 0.5. For x equal to 1 means you are adding across all the y's. For all the y's multiplied by 1. So 0.5 for 1 into 1. Similarly 0.5 for 2 into 2, which is coming out to the same 1.5 itself. And even given y equal to 10 also, even if y equal to 10 is given, then only this part you are taking and you are finding out for x and y separately. The conditional probability is what you are finding out. So the conditional probability for this is 0.2 by 0.4, which is 0.5. This is also 0.5. So you are multiplying 1 into 0.5 plus 2 into 0.5, giving you 1.5. That is in case of discrete. In this case, even if it is not given y equal to 10, the conditional expectation came out to be the same, because across all the, for all y's, x equal to 1 is nothing but 0.5 itself, the probability. So adding up 0.2 plus 0.2 plus 0.1. So in that case, it is coming out to 0.5 and 0.5 only, but it is not the case always. Now, what do I do in case of continuous? The same logic. So, because I want to find out the expected value of y, right here, I want to find out the expected value of y. So, I have to multiply the y with the conditional probability given x. So, how did I do the conditional probability here? In the discrete case, the probability of this divided by the total probability of this. This is what we have done. Here also, the probability of this, which is a combination of x and y, the probability of x comma y divided by whatever is given, the probability of whatever is given. In this case, y equal to 10 is given, which is, that's the reason we have divided by the probability of this entire thing. So if x is given for us in this question, the probability of x, which is f of x, that we are multiplying it by the corresponding values of x here. So here we have to multiply it by the corresponding y, and we are integrating it across the whole y. And how do I get f of x here? F of x is nothing but the marginal distribution, marginal probability of x, which means across all y you have to integrate it. Now let's take one numerical which will do the entire job for us and try to solve it. Let x and y have the joint density function given by, so f of xy equal to 3 by 5 x into x plus y. So probably 3 by 5 into x squared plus xy. Okay. Where 0 is less than x less than 1, 0 less than y less than 2. Now I need to find out the conditional expectation of y given x equal to x. So for that, f of x comma y is available with me already. This is f of x comma y. Now I need to find f of x which should be in the denominator, which is nothing but the marginal density function.